Okay, so hi everyone, welcome again. I hope you all are doing great. In the last live stream, we have covered the architecture of JSON RPC server, and in today's live stream, we will start with a short summary of what we learned in the last live stream and see how everything fits together to support the smooth blockchain operations. And if you wish to watch the last live stream in detail, you can check that out on our YouTube channel. It's under the Build-in Public live stream playlist. So yes, we are hacking on the JSON RPC server. So JSON RPC server, it allows users to interact with the Shardeum blockchain using JSON RPC instead of HTTP. It also includes a REST API for debugging and monitoring purpose. It simplifies the server status checks, error detection, and performance monitoring. As you can see, I'm inside the SRC folder. Let me zoom this a bit. So yes, I'm inside the SRC folder. Here we have a file called config.ts. This file is like the brain of the Shardeum JSON RPC server. It holds all the settings in one place. It's super convenient for the developers because it lets you control exactly how the server works. Whether it's connecting to networks, interacting with the blockchain, keeping everything secure, or integrating with the other services, config.ts, it has everything covered. This flexibility means that you can customize and tweak the server's behavior however you want, whatever your requirements are. And it's all about making the server work just right for you. In addition, we have some other files like blacklist.json, um, we have spammerlist.json and whitelist.json. Basically, they let you customize the IP addresses and domains that you wish to allow, block, or add into spam. Now, moving on to some other files, we have api.ts file. In this file, we have defined the methods that are available for the JSON RPC server. If we scroll down, right? Okay. So as you can see, as we are scrolling down, we have get current block info, and several other JSON RPC methods that we have added in the api.ts file. Um, yeah, so let's go now to the routes folder. Here we have two files, authenticate.ts and log.ts. It defines a different endpoints for the server. Each route corresponds to a specific RPC method. And for the authenticate.ts file, this file mainly handles the authentication using JWT, JSON Web Tokens. It defines routes to authenticate a user and verify its tokens. Another file that we have is log.ts. This file handles all the logging. It sets up routes to log various events such as when does the function starts, when does the function ends, and errors. So if you see here on line number 122, we have API stats. And on line number 237, we have clean stat tables. So basically, these are all the functions trying to fetch, that it's trying to capture these events and basically store them for debugging and monitoring purposes. So that was about routes. And if you see, we have another WebSocket folder. So it's responsible for handling all the WebSocket connections. It parses and processes JSON RPC requests, manages EVM specific subscription, and sets up event handler for managing the lifecycle of these subscription. Some of the examples include eat subscribe, eat unsubscribe. And if you go to like index.ts file, you can actually see these methods. On line number 91, if method name is equal to each subscribe, uh, you know, we have a complete function defined on what's it gonna do. And similarly, we have it for each unsubscribe. So this is what's happening in the WebSocket folder. So, up to this, it was a very, very brief summary of what we covered in the last live stream. If you want to see it in detail, I would highly recommend you to check out our YouTube. Now let's hack onto some other folders and see what other files are doing and how they are integrating well with each other. We have a folder called middlewares, and inside this we have three files: authorize.ts, injectip.ts, rejectsubscription.ts. What middlewares do? They typically contains several files, as we have seen. Each implements a different middleware function. These functions can include authorizing, logging, authentication, validation, any sort of error handling, and more, depending upon the behavior of our project. So now let's look at each file, go through all the functions and what it's doing. So as you can see inside the authorize.ts file, we have a function called authorize that basically checks for an authorization token in the request header. If the token, and also it accepts three parameters: request, response, and next function. So if the token is not found or it's missing, it's going to respond with a 401 error saying that no token is provided. And let's suppose the token is found, the jwt.verify on line number 13. This function is going to check the validity of the token using a secret key. And from where does this secret key comes? It comes from the config that is provided by the config file. So the jwt.verify, this function, it checks the validity of the token using the secret key from the configuration. If the token is invalid, or in case the verification fails, it responds with a 401 unauthorized error and a message that indicates that request is not found. But let's suppose they found the token and it also matches with the secret key. What it does is it goes to the next function on line number 18 to pass control to the next middleware, or you can say to the main request handler. So basically, what authorize.ts file is doing in short is it's the middleware for authorizing request. How? Using JWT tokens. Now, I hope this is clear. Now let's go to injectip.ts file. Okay, so this is kinda same as we did for the authorize.ts file. On line number 4, we have a function called injectip that takes three parameters: request, response, and next function. Okay, so if it defines the inject IP middleware function, and it checks if the request is each send raw transaction, and also whether config.record transaction status matches, and if both are true and valid, it goes to the next function. Okay, so so if both conditions are met, it proceeds to modify the request parameters, as you can see here. It modifies the request parameters to inject the client's IP address at index number 1000, and it calls the next function to pass control to the next middleware function in the request processing pipeline. So in short, what injectip.ts file is doing is it's a middleware for injecting the IP address into specific transaction requests. Yes. So this is the last one, reject subscription.ts. So at line number 3, we have a function called reject subscription, and same it also takes three parameters: request, response, and next function. So here what's happening is this is basically the middleware file that intercepts requests to handle EVM subscription methods like eat subscribe and eat unsubscribe. So here what it's doing is it checks if the request method is either eat subscribe or eat unsubscribe. Okay, let's suppose the method is eat subscribe. It's gonna throw error saying that HTTP doesn't allow eat subscription method. And if either the condition is true, it sends a JSON response, indicating this. But if the function is not eat subscribe or eat unsubscribe, it goes to the next function. Okay, so basically these are the three files: authorize.ts, inject ip.ts, and reject subscription.ts that we have in the middleware. They basically act as a middleware before processing the final state, and they are essential for managing various aspects of request processing. And we have seen how it can be implemented and integrated into a JSON RPC server. I hope it was clear. Um, Now let's check out some of the other folders. So we have another folder, another important folder called utils. So what utils folder is doing is, in general, they are typically imported into various parts of the application wherever their functionality is stated. For example, in the middleware functions, route handlers, or other modules that require specific operations, they are provided by these utils. By centralizing the common functionalities in the utils folder, the project promotes code reusability and also the maintainability. Developers can leverage these utilities across different modules without duplicating code, and it reduces the potential bugs and also improves the code consistency. So, for example, you see here we have nested count assist instance. If you will search for this inside our project, you will see how many times it has been used in different files. So basically, it's helping us to reduce the duplicate code, and if we have less code, it means there are less potential bugs, and also the consistency is very much improved. So that was all about utils, and there is one more important file called logger.ts. So what this file is doing is, in what it makes sure that our application, it remains robust and observable. It helps in logging various events and managing transaction statuses within our application. I'm not going in deep, to describe every function in this file, but this is the very brief overview of what logger.ts file is doing. So till now, we have learned what different files and functions are doing. Now let's learn how they, integrate with each other. So the first step is initialization. The server, when it starts its execution, it starts from the index.ts file. So index.ts, it's basically its entry point, and index.ts, it loads the server configuration settings from the config.ts file. Here is the config.ts file. And then we have the middleware. Middleware is used for handling the requests that are configured and initialized from this directory. So once we have the process initialized, the second thing is request handling. Requests are routed based on their type, whether they are JSON RPC requests or REST requests. We have a folder called routes that takes care of this. It authenticates all the methods, and uh, and yes, again, it depends what kind of methods they are. Once the request handling is done, it again goes into the middleware. Middleware functions are basically applied to all the incoming requests before they reach the route handler. Uh, so here, as I recently mentioned, we have three types of middlewares. One is authorize.ts, inject.ip.ts, and reject.subscription.ts. Each file is doing its own behavior, and one by one, the function passes through each of the files. And once it passes through the middleware, the next step is validation. We have a directory. Um, okay, yeah. So, yes. So, inside the external folder called servicevalidator.ts, so it goes through request data validation functions. Basically, all functions go through them, and it ensures that all the incoming requests data conforms to the expected format, and it has to be of the same rule. For example, if you run any JSON RPC method, there are specific parameters that needs to be output. So basically, it makes sure that what is expected and what our output is coming, they basically match with each other. So once that is done, it goes through the route handlers again. They process valid request based on their routes, and then we have the utility functions. Basically, the handlers utilize utility functions to perform all the necessary operations like database interaction, data processing, and at the end, we have a response. Responses are generated by the route handlers so that they are formatted appropriately. Errors encountered during processing are handled within the route handlers only. And then, as we mentioned, we have a logger.ts file that helps in erroring and displaying all the important events that are logged using the logging middleware, um, or directly within the route handler. This was sort of an overview how this is interacting. Uh, this was an overview specifically for the JSON RPC server project, and we have several other projects as well that it integrates. I would highly recommend you to check our GitHub. It's on github.com/Shardeum. It has all the open source project. But coming to the architecture of JSON RPC, I hope this was clear, like what each file is doing and how each file is interacting with each other. We have documentation available as well on our docs. So if something is not clear, I would highly recommend you to check it out or ask your questions in the chat or over our OSS devs channel. I'm just gonna stop sharing my screen and go back to Discord.
Thank you so much, Sonia, for that wonderful presentation. If you're joining us for the first time, we do these live streams every week at the same time, and we try to go over the open source repositories that we have here at Shardeum. And some other times we build some interesting projects, right? The last time I think we built a Shardeum status monitoring site. If you want to catch up on all the previous sessions, check the Building Public playlist on the Shardeum live stream on the Shardeum YouTube channel. You will catch up on all the previous sessions. And if you want to keep yourself informed of subsequent sessions that we have coming up, you can go to the events tab on the Shardeum Discord server and just RSVP to all the upcoming sessions. I think next session we're going to be let me quickly take a look. We're going to try to understand the transaction lifecycle on Shardeum and how Shardeum processes transactions. So if that is interesting to you, just go ahead and RSVP to that event, and when it starts, you will get notified. So thank you all for joining us this week, and we hope to see you again next week. Sonia, do you have any closing words?
I guess you have covered it all. Thanks everyone for joining. Looking forward to the next live stream.
All right. Thank you very much, and bye everyone.